Welcome to Okolab YouTube channel. This is an overview of Okolab stage-top incubation systems for time-lapse microscopy. Here's what we'll cover. What is time-lapse microscopy? What are the components of a stage-top incubator? What are Okolab's stage-top incubation offering, Bold Line fully digital and UNO THCO2? We will then compare them side by side. Time-lapse microscopy involves imaging cells on more than one point in time. You may need to study cellular processes that occur over hours or several days. To keep cells alive while on the microscope, you have to control temperature, gas concentration, and humidity. This slide shows you the two Okolab offerings for stage-top incubators. On the left, what we call Bold Line. On the right, what we call UNO THCO2, T for temperature, H for humidity. Let's see them in more detail. Okolab stage-top incubators have a set of controllers for temperature, gas, and humidity. On the left, you can see an overview. The temperature controller has several heating channels and is connected to a stage-top chamber. We control the temperature of each part of the chamber: the lid and its heated glass and metal frame, the base, and a channel for the objective heater. Both heating and gas conditioning are provided by the Microenvironmental Chamber, compact and easy to remove, offering a fast thermal response, and remember to use an objective heater if you're imaging with an whole immersion objective. This slide shows you a complete Bold Line stage-top incubator. Let's see it in more detail. On the left-hand side, you can see a stack of controllers. They are digital for temperature and gas. The controllers are linked through a bus connection shown on the right. Each stack is operated through OkoTouch, a user-friendly and intuitive touchscreen interface. The intuitive touchscreen interface displays readings from all the temperature sensors. The system automatically adjusts the temperature of each component to ensure that the sample is at the desired set point. Monitoring the room temperature, controlling the temperature of the chamber lid and base, and showing sample's temperature if you operate in sample feedback mode, and the objective heater. The OkoTouch overview page displays the set point of each gas, in this example CO2 and O2, the total flow rate, as well as relative humidity. You can input the desired set points from the home page. To input the desired temperature set point, you press on the Temperature tab. To input the CO2 concentration, as in this example, you press on the CO2 tab and adjust the set point. We offer various digital gas mixers depending on what you want to control. They all have the same footprint and offer 0.1% accuracy on each gas. The most common mixes CO2 and air. There are options for hypoxia and hyperoxia. Air contains about 20% oxygen, and to remove oxygen from it, one uses nitrogen, essentially displacing oxygen molecules from the gas mixture. To generate hyperoxic conditions, you want to enrich air with additional oxygen. You do this by actually adding oxygen. In both cases, the digital gas mixer can also operate in what we call air mode, mixing CO2 and air without controlling oxygen. OkoTouch is an intuitive touchscreen interface. It has onboard memory to log the data. Temperature can be controlled using sample or chamber feedback mode. Humidity control is active. The humidity module, located away from the stage to avoid accidental spills, is equipped with a humidity sensor. There is no need to add water into the chamber. The system is compatible with the SmartBox, an optional device allowing you to log the data and control the unit remotely. Manual gas mixers are compatible as well. This slide shows you the level of control of the active humidity module. In simple terms, to generate water vapor, you have to warm up the water. Hence, the bottle is sitting in a heated base. The vapor phase is above the water, where gas flows and gets humidified. Our in-house tests determined that there's no need for a bubbler. The level of humidity is measured by the humidity sensor lid. The feedback loop automatically adjusts the heating components to reach and maintain the desired set point. This was a brief description of the Bold Line controllers. To inquire about different options, please contact us at info@oko-lab.com. Let's move on to the UNO system. Let's see it in more detail. UNO THCO2. T stands for temperature, H for humidity, and CO2 for gas mixing. We offer various combinations of this system depending on budget and needs, such as use with premixed gas, temperature and humidity only, or temperature only. UNO is compatible with all Okolab heated stage top chambers. Let's see it in more detail. The temperature controller is digital. The user interface is again user-friendly and intuitive. Similarly to OkoTouch, UNO allows you to log the data either on external storage or on the onboard memory. The digital temperature controller offers 5 integrated heating channels. The heating channels controls the humidity module, heated base and heated and insulated tube, the temperature of the lid and the base of the chamber, as well as the objective heater if you're using one. UNO THCO2 includes a manual gas mixer for CO2 and air, and an air pump. The humidity module is open loop. It includes a heated base and a heated and insulated tube. The tube carrying humidified gas to the chamber has to be heated and insulated to avoid condensation along its length. You enable humidity here, and you input the room temperature here. The temperature performance of UNO THCO2 and Bold Line is the same. UNO THCO2 and Bold Line are both compatible with Okolab stage top heating chambers. The difference is in the gas mixer used. A manual mixer involves using floating ball flow meters and offers a 1% accuracy. The digital gas mixer has 0.1% accuracy and a user-friendly interface. Humidity on UNO doesn't have a sensor and is not automatically adjusting if the room temperature fluctuates. HM Active uses feedback to ensure the desired relative humidity. Both use a bottle where you can see the water level and can add to it without perturbing the sample. I remind you that Bold Line and UNO are compatible with all Okolab stage top heating chambers. Let's see some common ones. To illustrate the chambers, I will use a K-frame as an example. A K-frame chamber fits stages with an opening 160 by 110 millimeters. Chambers for all stage brands and models, including upright, are available. Okolab K-frame chambers have built-in perfusion holes. They come plugged in with small screws. You can unplug them if you need to do perfusion, as illustrated in this example where you can see tubing. The lid slides open, and you do not have to put water inside the chamber to provide humidity. The sample is placed in the chamber using a magnetic insert. Okolab chambers are compatible with microfluidic experiments or perfusion, as they have built-in perfusion holes. However, you can also select a microfluidic chamber riser. It replaces the top layer of the chamber. It can be removed and installed using the provided screws, and it allows to rest and secure tubing over the chamber walls rather than thread them through the perfusion holes. This slide shows you a partial list of sample inserts. Please focus on the inserts in the red box. These are meant for multi-well plates. A stage-top incubator will require a perforated metal plate to improve thermal uniformity on the bottom surface. However, if you're using an oil immersion objective, the insert for multi-well plates will be an open frame, as shown in the blue box. This will allow the objective to move freely between wells. Here is an example for upright microscopes. It's compatible with multiphoton applications. There are several components to the chamber. From the bottom, a heated base with an adapter to your specific stage, brand, and model. Chamber walls, a heated lid. The heated base is secured to the stage. The chamber walls are set in place, and the heated lid slides onto the walls to find your region of interest. The opening on the lid is for the objective. You could use any objective, including water-dipping ones. We provide objective adapters, the semicircles in gray, to minimize the gap between the heating lid and the objectives, reducing humidified CO2 dissipation. There are 5 available sample inserts for this microenvironmental chamber. Active humidity control prevents excessive media evaporation. This slide shows you the stage-top chamber for upright microscopes. There is an opening in the lid for the insertion of the objective. The small gap between the objective and the lid, as indicated by the red arrows, is a route for excessive evaporation. In this instance, active humidity is required. When imaging with an oil immersion objective, we recommend using an objective heater. In this image, represented by a heating band, here in yellow, secured around the objective by a green strap. An oil immersion objective will touch the bottom of the well through the oil and will draw heat away from your sample. This is why an objective heater is recommended. So how do you choose between UNO THCO2 and Bold Line? The temperature performance is exactly the same. UNO is more appropriate for a conservative budget. Bold Line is fully digital, and its sensor for CO2 is more accurate. If you need active humidity module because you're using an upright microscope, you have to select Bold Line. Data logging is a feature that both have, but with Bold Line you're logging data for temperature, gas, and humidity. UNO allows you to log only temperature data, as that is the only digitized control. The gas mixer is manual and humidity is open loop. Thank you for your time. If you have any questions, email us at info@okol-lab.com.